I feel like Rob and I we didn't plan this, but I feel like our talks work very well together. So Rob was like, what are all the things outside of the actual Rust code that you need to worry about? Like how do you set up the crate, the CI, the cargo manifest, all these things. I will talk about none of those things and instead talk about how do you build an API for your crate? You want to make a library, you want it to get millions of downloads. What are some things that you might want to consider? Like what are some things that I have learned over the last 2 years of maintaining a somewhat successful crate? So this is API evolution in Axum. My name is David. I'm part of the Tokyo core team. I work on Axum, which is a web framework. I work on Tower and Tower HTTP as well, which is sort of the middleware service abstraction that underpins a lot of these libraries. And I've done a lot of work on Tonic as well, which is a gRPC implementation for Rust. By day, I work at Embark Studios, where I work on video games, and that is my handle on all the platforms, basically. And that is my dog. So if you're not familiar with Axum, it's a web framework. It's sort of in the same vein or scope as like Actix Web, Warp, Tide, Rocket to a certain extent. That has a slightly bigger scope, but still. This is sort of what the API looks like. So there's a router type. You say .route, you give it a path, and then you tell it, I want for the get method, I want to call this function. You can select for users, I want to handle get and post, and you can as well like make a separate function. You can call .layer and give a tower middleware. So the trace layer is not specific to Axum. It can technically work for other frameworks as well that integrate with Tower. And then Axum has a way to share state in sort of a type-safe way all the way down to your handlers. And then the handlers, we use the extractor pattern, which is fairly common among Rust web frameworks, where the function arguments sort of dictate how you want that data to come in. So the fact that we use the JSON type, that sort of tells Axum that I want to parse the request body as JSON, and then use Serde to deserialize it into this type. And then you can sort of do whatever you want inside the function and return out some type that can be converted into a response. So in this case, we use JSON as both an extractor and a response. And when used as a response, it'll encode things with Serde JSON and set the right content type and do all those things that you'd expect. So this is sort of what Axum looks like. Hopefully it gives you sort of a feel for the API. And then obviously to run the server, you give it to Axum server, which is really just a re-export of Hyper server. So Axum does not have its own server built in. We fully leverage Hyper to do all that busy work. And then you call into make service, which is a Tower thing, and then Hyper will go ahead and actually listen on the connection and serve HTTP requests and do all that stuff. So Axum came out in like almost 2 years ago, and since then we've had a more or less regular cadence of breaking releases a couple of times a year. Currently we're on 0.6, whereas 0.7 is still in the works. The main feature of 0.7 is that we're going to have support for Hyper 1.0. So they're going 1.0 sometime soon-ish. It's still work in progress. The estimation was that it would be by the end of last year, but you know, like software and estimations, that doesn't always work. So whenever Hyper 1.0 comes out, Axum 0.7 will also come out. And we're not 1.0 because Tower is not 1.0 and Tower is in our public API. So like Rob just said, we have non-1.0s in our public API, so therefore we cannot go 1.0. We have a lot of downloads. It may or may not be the most downloaded web framework on Crates.io. I'm not going to tell you whether these are the downloads for Axum or the downloads for Tonic. You'll have to figure that out yourself. We have slightly less stars than Actix Web, but you know, we get a lot of use and a lot of downloads, which is cool. This was the last one. This is the last one, I promise. All right, the first thing I want to talk about when you're building a library is that you should not be afraid to start. I get this question somewhat often when like, how do you make a web framework? Like, where do you even begin? I'm like, you just begin. Like, you figure out how you want your API, your code to look like, and then you slowly build features and you iterate and you evaluate as you go along. There's really not a lot to it. Like, you just kind of start working on it, and then over time, like 2 years later, you have a big ecosystem of crates. So what I did for sort of the pre-1.0 days is that I was like, my idea for Axum was that I wanted a sort of Tower first web framework. I had done a lot of work with Tower during my day job and also as part of Tonic. And I was like, I think Tower is really cool. What if we had a web framework that was sort of built on the fundamentals of Tower and really embraced that ecosystem? So like routing was not really important to me. I was like, you need a way to put routes together. I don't really care what that looks like. What I care about is how does this integrate with Tower? So I was like, let's just pick an API that some other framework has. And I was like, Tide is pretty good. I've used that in the past. So I just like stole their API just sort of so I could experiment myself. So in the very beginning, this is like the third or fourth commit, something like that. This is not the API that we ship with. You could call like app and say .at and give it the path. And then you can say get route, and that will then add a route for get / that will then call this route function. In the early days, we didn't really have extractors. The first argument had to be a request, and you had to return a result of a response on error. That stuff came a little bit later. And so if you've seen Tide, this API is very similar. It works the same way for adding multiple routes. So at / get route, and the same for get and post for users in this case. And in the early days, the extractors were always the second or third or fourth argument, but request always had to be the first argument. It took me a while to realize that request in and of itself could also be an extractor. That was not obvious at first. And obviously today, you don't always have to return a result if your handler can't fail. So this was what the API looked like when I was just sort of getting started and playing around and sort of getting a feel for what I wanted. But this is what it looks like today. So how do you, like, what are the choices that makes you go from here to here? And why didn't we keep the Tide style of API? And there are a few reasons. The first one is that you have to define a bunch of methods twice, which is just sort of annoying. So you notice that whatever the app function returns, we have to be able to call at on that thing. And whatever thing get returns, we have to also be able to call at on that thing. So we sort of need two types that both define an at method, which is just sort of annoying. Like if someone is in your docs and they search for the at method on docs.rs, they're going to see two results. And it might not be obvious which is which. And then also from like a maintainer point of view, do we duplicate the docs on both methods, or does one link to the other, and which is then the proper one that has the docs? It's just sort of, it's a little weird. And it doesn't scale very well, because you can imagine you might want other methods that you can call in both places, like layer to add a Tower layer, that's a middleware, or to compose different routers together. And suddenly we have like 4 or 5 functions that are defined in both places. And that's a little weird. So that was one thing that I didn't really like when I was building out this API. Another thing is, how do you add middleware? One thing that I really wanted was for you to be able to add middleware like anywhere, basically. You should be able to hook up a Tower middleware on the whole router, on an individual route, or on like only get or post at some certain path. So I wanted sort of deep integration with the middleware side. And this API didn't really enable that. So you can imagine if I want to add just the timeout middleware to the post/users, you could do it the top way. You could also sort of do it the bottom way, where instead of calling layer on whatever post returns, you call layer on the handler type itself. Both of these could probably work. But then you're like, what if I have like multiple routes? And let's say that I only want the middleware for these 2 routes. So I don't want a middleware up here. What do you then do? Well, if you do the top one, where you call layer at the very end, this sort of seems like you're adding the layer to everything above it, which includes root, which is not what we want. And then if you do the other version, where you have layer at the very end, now you have to repeat timeout twice, which is just sort of, it's not the end of the world, but you know, it would be nicer if we could only say that layer once. You could imagine that you have a way to like build the 2 routers separately and then combine them together. So in this case, merge would take all the routes here and sort of merge them in with the top routes without reapplying the timeout layer up here. But now there's just sort of a lot of ceremony already to do something that, for me at least, I want it to be very simple and sort of first class in the routing API. So this is what the API looks like in Axum today and what we actually ended up with. So you can see that here we define 3 routes. We define get and the root, and then the get and post on users. So you can call .layer at the very end, and this will add the middleware to everything above it. So in this case, all the 3 routes, they all get the logging middleware. And then for get and post, we can say dot layer here. So it's the same method, it's the same sort of idea. That all the routes above this one, which is get and post, they both get the auth middleware, but only the users create one here gets the timeout middleware. And this was basically what we wanted. So the very tight control over where you put the middleware. So this was why we sort of moved from the tides API to the routing API that we have today. And these are some of the things that you can think about when you're sort of experimenting with different API designs. Any questions? Yes?
I'm not sure if I'm taking fast enough, but wouldn't this mean that you need to have multiple layer methods?
Yes, that's true. So that's a trade-off. Yeah, that's right. You could maybe cheat and use like traits with a layer method and then implement that for multiple types, but that's a trade-off in a different way. It's not necessarily easier or better.
I think you're kind of getting back to the same issue as you started with, that having multiple app functions.
Yes and no, because like we have different types, but they also sort of do different things, right? Like this one, it doesn't add it to all path route at the top. This layer only knows about HTTP methods. So it's not really that, like the docs for those methods would not be the same. But you are definitely sort of right. It's a trade-off, yeah?
Did you ever consider expressing this with something not Rust and then passing it with a macro and emitting Rust? And if so, why or why not?
No.
Can you repeat the question?
Can I repeat the question? Yes. Did I ever consider parsing this in like a macro, some syntax that's not necessarily Rust? No. One of the goals for Axum was that it should be entirely macro-free. I've written a lot of proc macros and seen a lot of the good things that they can do, but also a lot of the bad things that they can do. They can tend to sort of, one of the things that I find is hard with macros is like people always say that it increases compile times. But for me, the biggest thing with macros is that they prohibit or they make it harder to abstract stuff. Because what can you can only build more macros on top of macros. Like you cannot have a function that takes a bunch of arguments and some types and returns a macro. That doesn't really work. You can only have a macro that looks at the syntax of another macro and changes it. So what I really wanted for Axum is that it should be a thing that it should be a library that's easy to build stuff on top of. And I find that macro-free APIs make that much easier than macro APIs. That was why I wanted an API that was free of macros. Yes?
The middlewares on the right side of this slide says logging auth, and logging auth timeout. Are they executed in a specific order, the middleware?
Good question. So are the middlewares executed in a specific order? Yes. You can kind of imagine a middleware as when you add it, it wraps around all existing routes you have. So it becomes kind of a layer, or an onion rather. So if you add another layer here at the bottom, I don't know what that would be. Let's see, we add compression here. Then compression would run first because that's on the outside of the onion, and then logging would run second. It then becomes a little harder to see when do these middleware in here then run. I believe in this case, compression, if we were to add that here, would run, then logging, then auth, and then timeout. So it sort of wraps everything above it, if that makes sense.
Timeout would run first.
No, because in order to call this function, you need to first call the auth middleware, because that wraps this function, which is itself wrapped by timeout. We have a docs page for how middleware ordering works. It's a common question, and I think in Actix it's actually opposite, where they run top to bottom. I may be mistaken, but it's a trade-off. I don't think necessarily one is better than the other, but it is something to be aware of for sure.
Yes, roughly, could you explain the interface for a middleware, like what does it take in and what does it?
What is roughly the interface for a middleware? So in Tower, a middleware is just a function that takes a request and returns a response. That's basically it. And it can either be what we call a middleware, or sort of a wrapping service, in that it's like a logging middleware that itself wraps another service that might be a compression middleware that then eventually hits what you call a leaf service, which is like, I am the service at the bottom of your tree that actually produces the response, and then it sort of bubbles all the way up. So it's sort of like function composition, where you wrap functions inside other functions. That's sort of the model.
Am I right in saying it used to be the other way around for axum, like the layers would stack the other way around?
So the question was, did the middleware ever used to stack differently in a different order? I don't think so. What's really funny is that if you use Tower's service builder type, which also has layers, that one has opposite ordering. Yeah. I actually think that like top to bottom ordering makes more sense than bottom to top, but you know, not necessarily one's better than the other. Okay, moving on. A sum of smaller parts. So this is sort of the idea of your library should be made up of small composable pieces that on their own make sense, and you can then compose those to build bigger abstractions. So we looked at this sort of routing setup before, and this is a router in and of itself that makes sense, and you can run it and serve lots of requests and all that. But what about like this thing in the middle? Like, it's not really connected to the router. It's just an argument that one of your methods get. Can you like run that on its own? And I think the answer should be like, yeah, sure, why not? Like, this is a router that doesn't care about the path. As long as it's a get and post, then it'll give you a response. I'm not sure that's super useful, but I'm like why not? I think that makes sense to run on its own. And the interface is the same. So there's just an into make service method. So it doesn't really matter if it's a full router or what we call a method router. And you can even go the next step and be like, what, just get on its own? Like, sure, that works too. What about just handler, just a function on its own? And we're like, sure, that works too. So this is a function that just, it takes any request and produces a response. So you can sort of use this to like bootstrap your own framework, or you can do your own complicated path routing, whatever in here. But if you just want to get started and not worry about all the details of how the request actually comes in, you can do that. And like the way that we just do this is just similar to the layer methods. We just define multiple into make service methods. It slightly bloats our docs. Again, it's sort of a trade-off that you have to make. In the case of the function, you need it on a trait, which we then define for functions with up to 12 arguments, I think. And I think it's important that these pieces sort of make sense on their own and are composable to like make a thing that's sort of bigger than the sum of the parts. And it also means that we sort of want to enable, like, so this thing, for example, is like an API router. It has two routes that are just under /API. You can imagine in like a big production app, you might have thousands of routes. It would be kind of nice if you could sort of break those out into their own router and say, just take whatever routes are in here and like merge them into this top one. So then you can sort of decompose your routers into smaller sort of domain-specific routers that make sense on their own. And like people go crazy with like having all their user routes in one module and the tweet routes in the module, and they sort of each merge themselves sort of up the tree. I don't personally follow this style, but it is a somewhat common question that we get in Discord. Like, how should I organize my routes? And this is one way to do it. A sort of thing that when you enable this sort of flexibility in the API, it also comes with some implementation challenges. One thing that we've spent a lot of time on in Axum is the idea of fallbacks. So a fallback just basically means that if none of the other routes match, then we call this function. Pretty standard use case. Pretty simple idea there. But then the question is, what if I have this API router that like has two routes or however many routes under some /API, and it has its own fallback. And I then merge this API router into some other router that also has a fallback. And like both of these make sense on their own, like a router with a single route and a fallback, that's fine. This thing up here with some nested routes and a fallback is also fine. I think it's important that the composition of the two also works. And this was a feature that took a long time to land in Axum. We used to say this is just not allowed, and it would be like a runtime panic that you couldn't nest a router that had a fallback. But in a somewhat recent version of 0.6, we do handle this properly. We call it fallback inheritance. And I think like stuff like this, it's important that you sweat stuff like this, because otherwise it sort of trips people up, because they sort of expect this stuff to work. That each individual piece makes sense on their own, so they should also make sense when you put them together. Any questions?
What will happen when you do that?
What will happen? Good question. If you call API / something that doesn't exist, it calls the API fallback. If the path does not start with API, it calls this other fallback, which I think is what you would expect. Any other questions? I think nesting is probably the single most complicated feature in Axum. There's just so many edge cases that you would never think of nesting. Like, what if you nest at an empty path? What if there's a trailing slash at the end? What if there are parameters in the nesting? What if there are wildcards in the nesting? There's just so many things that you need to care about. So if I could remove a feature from Axum, I'd probably remove nesting, but you know, it's an important feature, so we can't actually do that. Cool. You should try to make your API hard to use incorrectly. An example of this is, so you give Axum this handler function, and then, so you don't call the handler function here, you pass the function into Axum, and then when a request comes in, we call the function on your behalf. So how do I provide arguments to this thing that doesn't come from the request? Like, how do I get my database connection in here? And the answer that we had for that for the longest time was the idea of extensions. So on the request type that comes from the HTTP crate, which is separate from Axum, there's the idea of request extensions, which is basically a type map. So you can insert a value of a given type, and you can get a value out of the same type. So you can sort of think of it as it's a map where the keys are the types, basically. So extension would then be a layer, a middleware, that inserts something into the request extension, and then you can also use the extension type to extract a type out of the extension map. And then the big question is, what happens if you forget? Like, what happens if you don't add the necessary layer extension thing here? And the answer for the longest time was that it just returns a 500 at runtime. Like, it's an error, basically. We try to make the error message somewhat good, but you know, it still happens. It would be way nicer if you couldn't even run your app if you hadn't specified some of the required state. So this is what I mean by, like, it should be hard to use your things, the API, incorrectly. Like, when you know something is not going to work, ideally it would be a compiler. So in Axum 0.6, we introduced the with state type on the method, and then the corresponding state extractor. So it looks very similar to extension that we saw before, but this is actually type safe. So if I forget this with state call here at the end, then this will not compile, and you won't be able to run your code. And likewise, if I extract a type, but then I add the wrong state type here, it won't compile either. So the type is sort of carried all the way through. And the way that we do that is, this is the trait that you implement to make an extractor. So we saw like JSON before, that'll parse the request body as JSON. That means that JSON implements, it doesn't implement the from request parts, it implements from request because it needs the body, but it's the same sort of idea. So this is the trait that you implement to provide one of these things that can go as an argument to an Axum handler. And so the change we made was that we added this S type parameter here. So it used to be that this function down here only took one argument, which was the request parts. So that's stuff like the version, the method, URI, extensions, headers, stuff like that. That's sort of in the request. But now we also make sure that we pass in this S type here. And that means that we can make a state extractor, a state type, that takes the same S and then basically returns out an owned version of this S that gets in. Unfortunately, we cannot return a lifetime due to some lifetime borrowing shenanigans, so we have to require that S can be cloned. But this basically means that this S is now generic over an S. So that means the handler itself is also generic over the S. And then the method router that get returns is also generic over the S. And finally, the router itself is also generic over the S. So that state type is sort of carried all the way through the API. That was a big yak shave, and I think I changed all the files in Axum to make that refactoring. But yeah, some things that you sort of want to be aware of is, like, you, as much as possible, still want to make sure that things compose well. And you might say, like, why is it a with state method at the very end? Why don't you just provide the state to new? Like the Axum internals, there's a whole bunch of work, there's a whole bunch of sort of type tricks to know if the state has been provided. And if it has, then we can run the router. If not, then we can't run the router. Like, why don't you just put the state into new? Then it's always there. You don't need to sort of know at a type level if the state has been provided. And we did that. And we did that for a release candidate of Axum 0.6. But the issue is then, what if you have a nested router? So in this case, I have an API router that just makes sense on its own, and it uses the same state as the outer router does. It's sort of annoying that I have to provide the state twice, right? I just wanted to use the same state. And it gets even worse when you look at the example that we had before, where we had like an API module, a user module, and a tweet module. You might have many routes, and you're building your router out of hundreds of small sub-routers. If you have to provide your state each time you call router new, that's just a lot of like boilerplate that you ideally shouldn't have to write. It's just passing the state type around everywhere. It would be much nicer if you could just make your API router on its own, merge that in, and then the types sort of figure out which state type it needs, and knows that when you call with state at the very end, all the requirements are fulfilled, the state is there, we can now actually run. So this took a lot of work, but this is eventually the solution that we ship within Axum. So it composes really well. The downside then is that how do I get my state into middleware? And that stuff we don't have a great answer for yet, because all our middleware stuff comes from Tower, which does not have a concept of state. So that's slightly underbaked in our API. We do have solutions to them, but they're not great. Yeah, and you can sort of imagine that you might have your API router actually wants a specific state that's different from the state that the main router has. And we support this as well through some fancy type tricks. I'm not going to go into how this works. If you want to see the code, we can talk about it afterwards. But these are sort of considerations that you make when you introduce an API like this. And this was why we had several release candidates for Axum 0.6, because we knew that this was a key feature that people have been wanting for a very long time. So we wanted to ship it without committing to a sort of semi-stable API. So we got a lot of feedback and sort of back and forth with the people on Discord about how exactly this should work. Cool. So that was an example of where we go to the type tricks. But adding more types and more generics in places is always a trade-off, because if you sort of follow that all the way through, it sort of makes your API very hard to use as well. So you sort of have to judge, say, when do I go for runtime checks versus when do I go for the perhaps more complicated generic solution. So here's another case. What should happen if I make a router with a fallback, and then I merge in another router that also has a fallback? Like, which fallback wins? I don't necessarily think there's a good answer. What Axum does today is it just panics. It says, yo, you cannot have two fallbacks. That doesn't make sense. You have to fix this. You could say that, like, we dropped the first fallback and only use the second one. But then, like, what if they provided the second one by mistake and they actually want to use the first one? That can be sort of confusing. What if people are moving code around while they're refactoring and accidentally introduce a second fallback? So I don't think there's necessarily a good answer here. You could imagine that you add some, I don't know, maybe a const generic or some other generic type to the router itself that tracks whether a fallback has been added. And then we would only allow you to merge a router that doesn't have a fallback or something like that. Which, you know, we could totally do, but we choose not to, because we're like, you're going to see this compile error immediately when you run your application, because that's when you're building your router. Whereas the extension case, you're not going to see that until you actually call the endpoint that needs the extension. And that might be behind auth. It might require a whole bunch of services that you may not have set up on your local machine. Hopefully you have tests, but you know, not all people do. So that was why we said that having type safety for the states is more important than type safety for fallbacks. So therefore, we just use runtime checks for the fallback. Questions? Yes?
Could you have if you merge those two, have a default option that will replace the previous fallback, and then with an option to skip, like if you copy a folder onto a folder and it has some duplicate files, then you can either replace or skip
Yeah.
So the same concept where you have a default state option that it will either replace the inner fallback or just skip.
Yeah, so the question is, could we make it configurable, basically, where there's a fallback, where there's a merge that allows a fallback, and there's one that doesn't maybe use as default? Totally, yes. We choose not to. We try to not have much configuration at all, really, in the API, just to have as small an API surface as possible. Because the larger our API is, the more likely it is that we discover something that we want to make a breaking change to fix. So we try to have as little configurability as possible, and then decide on the good defaults. And how do you decide? Mostly it's just gut feeling. Yeah.
Maybe as a follow-up on that question, it's probably going to be a basic question, I'm sorry, but you mentioned already, you didn't show on the slides, probably because it would be too complex to put on the slide, but you mentioned that you impacted the whole code application of Axum when you introduced the state layer on the states. And that's, so there's now one generator that has polluted all three prototypes of, probably router, probably from request parts and one other part that I can't remember quite now.
Yeah.
But how are you 100% confident or close to it that there's not going to be something that you discover later on that requires that massive of a change? And how does that relate to API evolution? Is my question, I guess. How are you positive that there's not going to be something that's going to be a massive change later on that you can't because you can't do it because it will be just too large?
Yeah. So how do you know that you're not going to discover a thing that will require massive breaking changes tomorrow? I think is the question. You're not. Like you can't. I think every open source maintainer has this fear that as soon as they publish 1.0, someone's going to open an issue with a very valid feature request that requires a breaking change, and you have to ship 2.0, and that just sucks, and you don't want to. I don't think you can know. I think you can sort of incubate it for a long time, but then the question of how long do you wait? Like you don't know. I think it's mostly just a gut feeling thing, and also sort of trying to talk to the community and be like, what are the kinds of questions that people are answering, and then seeing if you can find solution for those. But you don't know that someone's not going to come with a feature request tomorrow that you really want to support. Yeah.
In Tokyo 1.1 or 1.2, we actually had like an entire feature we had to remove because we found it was like unsound. That happened just after the 1.0 release. It was pretty annoying.
Yeah.
But we decided to remove it since we just released on 1.0, so probably nobody's using it yet.
Yeah.
So it happens, and you can work around it.
I mean, worst case, you ship 2.0 next week, and it's not the end of the world. Like for Tokyo, where they have specifically, we promise to be 1.0 for the next 3 years and not ship a stable release because we want Tokyo to be very dependable. We can't do that. I don't give any such guarantees for Axum. I could ship a breaking release every day if I wanted. I won't because it'll cause a lot of churn in the ecosystem, but you know, for sure. Cool. Make common things easy. And this also includes decide what the common things are, which is usually the harder problem. So a common question that we get in Discord is, I have a handler function like this that returns returns one of multiple types. So it either returns some JSON, it returns a redirect, or it just returns an empty body with just the status code. And obviously in Rust, you can only return one type. So what should the return type be here? And the common answer that we have is you call into response on each of those, and then it becomes a response, and then that is just what you return. And that is, of course, possible because the into response trait is basically as simple as it gets. It just gets the receiver, so self, JSON, or redirect, or whatever, as the parameter, and then it has to produce a response. And we've gone through many iterations of this trait, making it more complicated with like associated types and additional parameters to this method and all sorts of back and forth. But this is sort of where we've landed so far. And a common feature request that we get is like, I would really like to see the request data while I'm generating this response. You can imagine that you want to look at the accepts header on the request to know if the client accepts JSON. And if they do, then you want to return JSON. Otherwise, you maybe want to return I don't know, XML or plain text or whatever you want. Currently, this is not something that we support. You cannot access the request data from inside the into response method. And then you can sort of say, well, why not? Why don't you support this? I think this is a valid feature request, but we've decided not to support it. And the reason is that like when we do this case that we did before, where we want to sort of unify multiple types, we were calling into response. And so calling that now requires passing in the request parts so we can see the headers and stuff. How do you get that in here? Like where does the request parse, where does it come from? And you can say, well, it could just be an extractor, right? You just extract it out and then you sort of pass it in. It's a little more boilerplate. I don't think it's too bad, but it actually turns out that request parts in and of itself surprisingly cannot be an extractor. And the reason is that the from request parts method, so that's whatever these types up here resolve to, we need to return an owned version of that. So we need to return an owned self here without any sort of lifetimes or anything on it. And so all what we get here is immutable parts. And parts does not implement clone because parts contains one of these extension type maps that we talked about before, and that is not clone. So you cannot get an owned parts from a reference, which means that this implementation, you cannot do that, unfortunately. It would be nice otherwise. You can imagine like maybe what if you allow like returning a reference here and then like that could resolve to a borrow or something like that. But then you're like, this is a mutable reference. So what if you have multiple extractors? Then you end up with multiple mutable references that all point back to the same parts and those end up overlapping. So it turns out that returning own data here, I think is the right answer. You basically cannot make it work with borrowed data, unfortunately. You can sort of go the other way and say like, maybe we have like an either type where you can sort of compose two of some type together, and then we're like, hey, either implements into response if both of the contained values do. And then we just match on which one it is, and we provide, and we call the into response method on that. And since we're like inside the into response trait, which is called by these sort of internals of axum, we can make sure that we get the request parts here. And you could do this. This could totally work, but it sort of pollutes the calling code a lot, where you end up with like this is sort of a nasty return type, right? And it's extra bad because like either takes two, it can compose two types into one, but here I want three. So it's like I want an either, which is, yeah, it's not great. You can make the return type up here slightly nicer by returning impl into response. This has other surprising issues. We actually don't recommend people use this unless you know what it means. A lot of people assume that impl into response means you can return multiple types, which is not at all what it means. Sometimes they put a semicolon at the very end here and they return the empty tuple, which implements into response, but it's just an empty thing. And then they make a YouTube video about it, and then that's really funny, and thank you, Faster Than Lime, that was great. So yeah, it sort of feels like there's no good answer, right? I don't know, I would like to support the use case of being able to look at the request in the into response, but I don't know how to do it without breaking this use case. And that's the question, like, you have to make the common things easy, but you need to decide on what the easy things are. I say that it is more important to be able to call .into response to unify multiple types. That is more important than being able to look at the accepts header in your into response implementation. And that's just like, that's a judgment call. Maybe I'm wrong, maybe I'm not, who knows? So yeah, you have to figure out what the easy things are and then work to make that easy in your API. So that's why the trait to this day looks like this. And it's not like you cannot do this at all. Like, we have less than ideal workarounds. Like, you can write your own accepts header extractor that like parses the accept header type and gives sort of a nice interface for that. And then you can do whatever you want in the handler itself. You can check it here, but you can also like this response type that you return, you can sort of extract the request data and pipe it into that. And then that can do that, or then it has the request data when you're calling into response because that's stored on this struct or whatever. So it's not like you cannot do this. It's just a little more annoying than it would be if you had if it was available directly on the into response trait. So this is the trade-off. We say we would rather have this than this, right? Questions?
I just I want to add some color there. Our responder trait, which is the same, is it does allow access to the request, but that's because we have different trade-offs, right? We have different recommendations and patterns, and both are valid. And I think this is probably one of the biggest differences between our two libraries.
Yep.
In terms of traits. To ask a question, I guess, why into response as a trait and not into? Okay, you're not looking. Wait, carrot response. What was I trying to say? Right. Why not the into trait here?
So the easy answer is that the trait hasn't always looked like this. It used to have associated types and all sorts of stuff. I think maybe we could, I'm not sure. We have a bunch of generic impulse for tuples of things that implement into response. Those also implement into response, and I don't think that we could make that work with the into trait. I also kind of like the symmetry of the traits are called from request and into response. That, I don't know, that sort of feels nice, but that's mostly superficial, I suppose. But yeah. Sometimes people ask also, can you make this trait async? And I'm like, yes, if you want to look at the database thing when you're generating the response, but you can still do whatever async stuff you want in the handler. So yeah, you're gonna get a lot of fun feature requests, and it's a lot about deciding what do you want and just saying no to stuff and have an opinion about things. And a lot of it is just gut feeling. I don't think there's any right answer here. Cool. So these were the 4 things that I wanted to mention. Don't be afraid to start. Just copy the API of someone else and see how it works and try to iterate on it. Try to build your library as a sort of sum of smaller parts where each of the parts make sense on their own and they can be composed. Try to make things hard to use incorrectly, but make a trade-off in how do you do that. Do you do that using complex generics, or do you do that using runtime checks? And then make the common things easy and decide on which the easy things should be. That was my talk, yeah. Question?
Yeah, so when will actually be 20 crates?
Do it.
Hopefully never. Tokyo used to be tons of crates, and then they merged that. And Tower used to be many crates, and then they merged that. Axum is 3 crates now. There's Axum Core, which has as little stuff as possible. It has the from request and into response traits. And that is, if you want to make a library that provides an extractor, you want ideally only to depend on those traits, because the API service is much smaller, so we're less likely to make breaking changes. You don't want to depend on the router. If I'm making a database library that I want to provide a nice extractor for, the routing doesn't matter. I just need the from request trait. So there's Axum Core, and then there's Axum itself, and then there's Axum Extra, which is similar to the Actix lab. It's just funny ideas that we have. We just put those in there, and then we make a breaking release more often. Yeah. Yes? How would I change or improve the routing system in Axum? I don't know. I don't think it's perfect. I think something that we don't have a good answer for is routing based on something that's not the path or the HTTP method. A common request is I want to route based on the content type. So if a JSON request comes in, or I don't know, a protobuf request comes in, I want those to go to different handlers. You cannot do that today. You can look at it yourself in the handler function that you write, but it's not built into the Axum router itself. That's a thing that I would like to support. I don't know how to do it. If we want to do it, I think we should find a way that doesn't make the rest of the routing more complicated, which is we've had some few contributors give ideas on how it could be done, but I feel like it sort of makes the rest of the API more complicated, which is not what I want.
Shouldn't that be an either-or kind of extractor?
Yes, you could do that, and that is the recommended case that we have today. We have an example of that in the repo, for sure. So you can write an extractor that gets the request headers and looks at the content type, and then it can deserialize the body in one or two ways. Yeah.
So since it's not 1.0, how would a 1.0 axum like potentially look like?
How would a 1.0 of axum potentially look like? I don't think I want to change much, honestly. I think that the overall shape of Axum's API has been the same since 0.1. I think like the way that you pass in the extractors, the way the router looks like, I don't think it has changed much. So really it's been sort of fine adjustments here and there. The biggest question is how are Axum's dependencies going to look for 1.0? So Tower is sort of infamous for having very large types with lots of like generic futures and all this stuff. And that's mostly due to a lack of like native async traits, basically, because the boxed async trait is not really the right trade-off for Tower, because it should be somewhat low level and performant. So when Tower is 1.0, that's going to impact Axum for sure. I don't think it's going to change the surface level API of Axum, but yeah. Like also Hyper going 1.0 has had Hyper working on going 1.0 has had a big impact on Axum, because Hyper is really slimming down their public API a lot and moving all sorts of Hyper. If you look at the API today, you'll see that there's like a high level API and there's a low level API, and they're only stabilizing the low level API. So all the high level stuff that Axum uses and has in its public API is being moved to a hyperutil crate. And hyperutil, similar to these other like experimental crates, will never be 1.0, because that's the whole point. If it's stable, then we can move it into the proper hyper crate. So like Axum re-exports hyper server, and that's going away. It re-exports hyper's body type, that's going away. So we have to define our own body type, and we have to define our own server type and figure out how to do that. Yeah, we're trying to do it in a way where it causes as little disruption as possible, but there will definitely be some changes.
You said there were 3 crates for Axum, but there's also, for example, something called Axum with live view, for example.
Yes.
You don't consider that part of Axum?
It's not in the main Axum repo. It's on my personal GitHub, not on the Tokyo GitHub. So it is maintained by me, sure, but I don't consider it sort of part of the core Axum ecosystem, no.
How do I know as a user?
If it's on the Tokyo GitHub organization, then it's proper.
Okay.
Yeah.
So one of the 3 crates that are on the official repo is Axum macros. And you mentioned that you were pretty adamant on adding macros on top of each other, because that turns quickly into a monster of procedural macros. How could you extend your take on why Axum macros exist, if your personal opinion is that there should not be such a thing as macro? What do you consider to be a good example of procedural macros that don't turn to monsters?
Yes, so what would be a good example? Like we have the Axum macros crate, and why does that exist if my stance is that macros are bad? My stance is not that macros are bad always, forever. I'd like serialize and deserialize is amazing. I would never want to use like anything that's not a procedural macro. I think SERDI is amazing. I think macros have their place. I think as a sort of core part of your routing API, I shy away from that. I don't want to use that. But like I think Axum macros has some really useful things. It has a macro called debug handler, which is like a godsend. So you run into very often that the sort of type gymnastics that we need to use to make the extractors of multiple arguments work really hurts the compile errors to the point where they're totally unusable. So we have a macro that you slap on a function, and then that magically improves the compile errors. I think that's a great use of macros. We don't recommend that you use that macro on all your handler functions all the time, but if you run into a type error that you don't understand, you can put that there. We also have a macro, like have a derive from request, for example, that just gives you. So if you have a struct with like 3 fields and each of those individually are extractors, then you can put those into one struct that'll just extract each in order. I think that's harmless. Generally, I think that derive macros are really good if what they do is sort of obvious. Like from request, it'll just call from request for each field in the struct. That's fairly harmless. Like serialize and deserialize is the same. but macros that will like rewrite your function to generate an anonymous enum so you can return types of multiple things and sort of do all that magic, which some people do. I'm personally not a fan of that. Yeah. So we do have macros, but they're not in the sort of main path that you do when you're using Axum. Yeah. And all the macros from Axum macros are re-exported by Axum itself. So that's why I say that there are 3 crates, because you don't need to depend on Axum macros. Yeah.
I'll start with derived from request is such a good idea that I stole it. It's in the lab at the minute. The other question I had was, what language features apart from async traits are you excited for to improve the API even further?
Ooh. I am not sure, actually. I think async traits is for sure the big one. Yeah, I'm not sure. Nothing off the top of my head. I mean, compile errors getting better would always be nice. Yeah, I think like we were all waiting for GATs for so long, and I have yet to use it at work or like in my open source. So like, maybe Tower will use GATs. We're not quite sure yet. Yeah.
So you mentioned that the labs crate, that like, we didn't call it labs.
We call it extra.
Extra.
Hyper calls it utils.
Yeah, we also have Tokyo utils, which is kind of the same idea. A bunch of random stuff that people contributed that we didn't want in the main Tokyo crate. I've kind of had the idea, maybe I should make Tokyo util like into a 1.0, or maybe just go straight to 7.0 or something to say, because like, I kind of want the ability to have patch releases separately from minor releases. But like, I don't want to give the impression that it's like stable in the same way as Tokyo is. I don't know, just an idea that you reminded me of, by something you said earlier.
Yeah, I think we could totally do it. I don't think it would really matter if it was 1.0 and then 2.0 the next day. I think it's mostly what you're saying about setting expectations of what a 1.0 means. Yeah. I don't have the line in the README that Rob has where like, this crate will never be stable, but like it will never be stable because that's the point of the crate. Otherwise it would be in the actual crate that is stable. So yeah.
Is there any like either design consideration or just concern as you're developing the API for compile times?
Yeah. Axum used to do the thing that Warp does, where the router type gets bigger as you add more routes to it. So we would never erase any types. And then I was on vacation one day, and there's a new release of Rust that had a regression in compile times for very large types. And it broke Axum. And I was in Greece, and my girlfriend got very happy that I had to submit a patch to Axum. Yes, what we do now, Axum, maintaining Axum over 2 years has basically been a journey for me to be like generics types all the time to now boxing and trait objects are actually fine. So the answer that we have for good compile times is we just box like stuff. We just use trait objects. So yeah. So we allocate more, and there's a little bit more pointer indirection, but like it's fine at the end of the day. You're still calling out to your database on every request, which is way longer than following a pointer somewhere.
Presumably no one's ever complained about that.
I'm pretty sure people have complained, but I'm just like, dude, come on, like, who cares? Yeah.